So guys, in this video, we are going to look after some of the problems which are based on the integrated rate equation and a half-life of the reaction. So of course, the first problem is in front of you. What is it saying? Calculate the time in seconds. Please mention when you are reading the problem, you just see that whatever the units they have given to you, because our final answer unit should be in the same unit they have given in the question. Okay, so calculate the time in seconds for the decomposition of nitrogen peroxide which follows, they have mentioned the order. What is that? First order kinetics when concentration of N2O5 is dropped. Concentration of N2O5 is dropped from 0.1 molar to 0.001 molar. And they have also given you the rate constant. And what is the unit of the rate constant? Per second. Alva, first order kinetics are the rate constant unit per second. And we know that concentration of the reactant with respect to time goes on decreases. And also they have mentioned that the concentration of N2O5 is dropped from ಹಾಗಾದ್ರೆ initial concentration ಏನಾಗಿರುತ್ತೆ ಇಲ್ಲಿ 0.1 molar ಆಗಿರುತ್ತೆ. After some time t which we have to calculate in seconds, it will be 0.001 molar. So whenever you are writing a problem, yes, what are the things first you have to write? The data given. Alva, what is the data? First of all, we have got to know that order is first order. Initial concentration within the square bracket R0 is 0.1 molar. Final concentration is 0.001 molar. Then you having the rate constant is how much? 6.22 to 10 to the power of minus 4 per second. So remember, data is must and should. Then afterwards what you are going to write? The formula. Why did I choose this formula itself? Because we know that it has been following a first order kinetics. And what does your integrated rate equation for the first order formula? It gives the rate constant is equals to 2.303 by T log of R0 by R. See, log at the base 10. Remember. Okay. Next what you have to do? The calculation part. Of course, what things I know? I know K. As we know, 2.303 is a constant. R0 is known, R is known, I want T. Just do the rearrangement. After doing the rearrangement, just you have to substitute whatever the given is there. Alva, K is how much? 6.22 into 10 to the power of minus 4. R0 is how much? 0.1 divided by 0.01. Yes. Now how this 0.1 divided by 0.01 you would be getting? Of course, Alva, in case if you don't have the calci also, you should be able to do it. Heng barkobodu now 1 into 10 to the power of minus 1 divided by 1 into 10 to the power of minus 2. So this minus 2 goes up, we'll be getting equals to 10 to the power of 1. Why I am saying it is 10 to the power of 1? Yeah, here is our answer. So 2.303 divided by 6.22 into 10 to the power of minus 4 log at the base 10 into 10 to the power of 1. So what it would be in the manner log at the base x into x to the power of n anta iddaga enagirutte nimma answer, it would be the value of n itself. So illi enagutte, here what is there? N is equals to 1. So of course the overall log at the base 10 into 10 to the power of 1 is how much? Is equals to 1. Okay, so then what you have to do? Of course, the whole product into 1. So just you have to take the ratio of it. So we are getting T is equals to 3.7 into 10 to the power of 3 second. Why I have written this second? Because the rate constant is also in seconds they have given. You have to minute things you have to notice over here. Since the rate constant is also given in seconds, we are getting our time as also in seconds. So 3.7 into 10 to the power of 3 seconds. Is that clear? So let us look after now the next problem. So this is somewhat important problem because by seeing the question itself you will come to know why I am saying it. Yes. So what they have given you as the question? Okay. So they have given you as 70% of a first order reaction Yes, can you see? 70% of a first order reaction is completed in how many? 23 minutes. Alva. Yeah. 70% of a first order reaction is completed in how many minutes? 23 minutes. See, they have given the time in minutes. What they have said, calculate the rate constant of the reaction. Of course, as we have dealt with our previous problem, it is also in the same way because we have to use the same formula as a first order kinetics. But what are they given? So they have given that T is given 23 minutes. And what they have said, 70% of the reaction is completed. Alva, there is no data for what will be the initial concentration and what will be the final concentration. But they have given us the hint. What is that? 70% of the reaction has been completed. So what I assume, let the initial concentration be 100%. Alva, percentage anta bandkula nimma mind set madkobidi. So let the initial concentration be how much? 100%. So ಎಷ್ಟು ಒಂದು 23 ಮಿನಿಟ್ಸ್ ಆದ್ಕೂಳೆ ಎಷ್ಟು ಕಂಪ್ಲೀಟ್ ಆಯ್ತು? 70% ಕಂಪ್ಲೀಟ್ ಆಯ್ತು. ಹಾಗಾದ್ರೆ ಎಷ್ಟು ಉಳಿದಿದೆ? ಹೆಂಗ್ ತಗೊಂತೀರಾ? ದಟ್ ಇಸ್ 100 minus 70 alva. So how much ever at time t, what is the reactant which is present in your system? That is 100 minus 70, that is equals to 30%. So that's why I said this is somewhat an important problem. So you have to write the data now. Okay, what is the data? Of course, t is equals to 23 minutes. R0, as I mentioned, let the initial concentration be 100%. Final concentration, what they have given us there, that 70% is completed. Hagare ಎಷ್ಟು ಉಳಿತು? 100 minus 70, that is 30% is the available final reactant in the system after 23rd minute. Okay, so now we have got the essential parts. Yes, remember, time is given in minute. So what will be the unit of your rate constant? Keep in your mind, it should be, what should be the unit? Okay. Now let us go with the formula. What is that? Rate constant K is equals to 2.303 by T log of R0 by R. Okay. So this you have to substitute. 23, of course, percentage gets cancelled. So I directly written as 100 by 30. Okay. So when you are taking the log of 100 by 30 ratio, you are getting as 3.333. Log of 3.3 is 0.5228. Remember, I have said many times, so how to calculate log and anti-log is very much important. Yes. So log of 3.33 is how much? 0.5228. So on substituting, what you are going to get? 2.303 by 23 into 0.5228. So now the final expression you are going to get as how much? 0.05235. Alva. So what will be the unit now? Can you please help me? Of course, the time was been given in minute and it is following a first order reaction. Hagare enagirutte 0.05235 per minute. That is the part. Alva, they have not said to convert it. Just whatever the answer you will be getting, it will just keep it in per minute. In case if they would say you to convert the minute to seconds, then you have to take a one more step. Okay, but they have not asked over here. So the rate constant 0.05235 per minute. This minute, why? Because whatever the time they have given is given in the minute form. Alva. Otherwise, if you're not getting, you can just substitute here itself. We want the rate constant 2.303 is a constant. T is the minute. Even though both concentration terms are having a unit, but what happens? They will get mutually cancelled off. So what is the unit you will be left out? Only with minute. That is also in the denominator. So final expression will be also in per minute. So in case if you're not able to remember, you can also substitute the respective units and you can derive the final unit of your rate constant. Okay. So now let us move to the next problem. So guys, now let us go to the next problem, which is of the same type but a slight difference. What is it saying? 50% of a first order is completed in 40 minutes. They are asking you to calculate the time required to complete 65% of the reaction. So what you can analyze from over here, basically they have considered a reaction. For example, I will be choosing it as A plus B is giving rise to C. So what they have done, when they saw it at 40 minutes, nearly this reaction has completed 50%. So utilizing the data, that is your R0 and R, they have calculated the rate constant. Now when the same reaction has been taken for 65% of the completion, what they have asked, what would be the time taken? Of course, so I would be getting from this 65% what values? I would be getting my R0, I would be getting my R. Of course, why did I choose this 50% over here? Because I needed my rate constant. You can ask me, sir, how does the rate constant can remain same? Please do remember that, as I mentioned earlier, unless and until the temperature does not changes, your rate constant for the same reaction remains constant. If the temperature changes, then only within also the same reaction, the rate constant also changes. But in this scenario, what has happened? The temperature is same in all the cases. So what happens? Whatever the rate constant you are going to get in 50%, yes, that similar rate constant can be utilized for the determination of your time for 65%. So let us go on with it. So first and the foremost thing, of course, I have written my data in this way, but how you have to write? At 50%, what will be the R0? What will be the value of R? And what is the time taken? Okay. So when you're choosing in that way, of course, write the formula. Then calculation part. 2.303 by 40. Yes, log of R0 by R. Remember, this R I have not taken as 50 from directly over here. Instead, what it is? It is 100 minus 50. The same way as we have done in our earlier problems. Okay, don't get confused. Then what would be happening? Of course, log 100 by 50 means log 2. Yes. So 2.303 by 40 into 0.3010. So what will be the unit of your rate constant? Basically, it will be also in minutes. That is 0.01733 per minute. So utilizing now 50% of this data, what we have done, 50% of the reactions data, what we have obtained, the rate constant. So now in the next part, now what you're going to do, utilizing the same formula, now what will be your R0 in that case? Of course 100. What will be the value of R in that case? Yes. So now R is given as what? 100 minus 65, that is your 35%. Alva. So the same way you had to substitute. So 2.303 divided by 0.0173 into log of 2.857. Of course, the value of rate constant we have obtained from our earlier step. On substituting, you will be getting the time in which one? In minutes. Why did you get in minutes? Because our rate constant is in minute. So whatever the time you will be getting, that will be taken in your minutes. Is that clear? Okay. Coming to that of your now next problem. What it is saying? 60% of a first order reaction was completed in 60 minutes. When was it half completed? So of course the same way, first what you are going to do, utilizing your 60% data, we are first going to find out what is the value of your rate constant. Alva. Then what they have said, when was it half completed? Half completed means what? The reactant has been reduced to half of its value. That means we have to obtain what? T half. But T half for which order? Of course it is for the first order. So therefore, what is its formula? 0.693 by K. Where we are going to get this K? From our integrated rate equation. So first you calculate the value of K. Of course, you are going to get as how much? 0.01527 per minute. Why per minute? Because the given data is in the 60 minutes. Yes. Now T half will be what? 0.693 by K. Just you have to substitute this K over here. So whatever the time you are going to get is 45.38 minutes. Is that clear? So these are some of the problems which we have solved in with respect to that of your integrated rate equation. So in our next video, we are going to solve certain problems with respect to that of your half-life of the reaction. Okay. So guys, as I said, Now let us deal with the problems of your half-life of your reaction. Of course, so what is saying? The decomposition of an ethane to methyl radicals is a first order reaction. So I got a hint that it is a first order reaction with a rate constant of 5.36 into 10 to the power of minus 4 per second. Okay, at 700 degrees Celsius. Calculate the half-life of the reaction in minutes. Can you see over here? Why I am mentioning over here? Because whatever the rate constant is there, that is what? In per second. Of course, utilizing this rate constant, whatever the T half I will be getting, that will be in seconds. So that is the reason they have mentioned over here that you have to calculate the half-life of the reaction in minutes. So you should pay attention in your question. Of course, we know what the T half is independent of the initial concentration of the reactant for first order reaction. So whatever the calculation is there, is very much easy, direct substitution. Whatever the data, the first of all you have to write the rate constant given, then the formula. What is that? T half is equals to 0.693 by K. Yes, the calculation is what now? T half is equals to 0.693 divided by 5.36 into 10 to the power of minus 4. Alva, the rate constant, whatever they have given. So when you do it, you will be getting as how much? 1.29 into 10 to the power of 3 seconds. Now I have to convert this seconds to minutes. How we are going to do it? Of course, we know what 1 minute is equals to 60 seconds. Then how much minute is equals to 1.29 into 10 to the power of 3 seconds cross multiplication. So nearly you will be getting as what? 21.5 minutes or 0.0215 into 10 to the power of 3 minutes. So just a direct substitution, just you have to remember the formula. But I would like to mainly focus on one of the most important thing. Yes, that is this reaction or this question. What it is saying for a first order reaction, show that time required for 99% completion. Please remember, for a first order reaction, show that time required for 99% completion is twice the time required for the completion of 90% of your reaction. In simple words, what I have to show that whatever the time required for 99% of the completion is 2 times the time required for 90% of the completion for a first order reaction. Question is somewhat confusing, but you have to just pay attention. So what will be your first tactics? Yes, first you calculate the time required for the 99% of the completion. So how are we going to do it? Of course, by using your integrated rate equation. The same formula, what will be your R0 for the first case? It will be 100. R will be what? 100 minus 99, which means 1. Substitute it. So what are we going to get? The time is how much? 99% is 2.303 by K into 2 times. Alva, the log 10 to the power of 2 I have got. Log 100 ulkonutte, log 100 na yav barkobodu 10 to the power of 2. 10 cancel ಆಗುತ್ತೆ. log at the base 10 into 10 to the power of 2 ಏನಾಗಿರುತ್ತೆ? ನಿಮ್ಗೆ ಅದೇ ಮೇಲ್ಗಡೆ ಏನು ಪವರ್ ಇರುತ್ತೆ ಅದೇ ಆನ್ಸರ್ ಬರುತ್ತೆ. Okay. So now let us do the same scenario for 90% of your calculation or the completion. So R0 will be 100, 90% ಅಂದ್ರೆ 100 minus 90, that is 10. So ಏನು ಬರುತ್ತೆ? 10 to the power of 1. So T90 ಏನು ಬಂತು? 2.303 by K. ಇಲ್ಲೇ ನಮ್ಗೆ ಆನ್ಸರ್ ಗೊತ್ತಾಗ್ತಾ ಉಂಟು. Just you take the ratio of both T99% divided by T90%. When you take the ratio, of course, you are going to get in this way. So T99% is equals to 2 times the time required for 90%. This is not only useful for this calculation part. Remember, it is a part which can be also used in your competitive exam. 99% time ಏನಾಗಿರುತ್ತೆ? If they have asked and they have given you the 90% time, it will be 2 times the time taken for the 90% will be giving you the time taken by a reaction to complete 99% of your reaction. So this is the important things you should keep in your mind. Okay. So these were some of the problems related to that of your integrated rate equations and some of with respect to that of your half-life of the reaction. Of course, I have opted on the some of the problems. There are many such problems you have to try to get a clear-cut knowledge that how to do it. Okay. So remember, whenever you have to solve this chemical kinetics problem, also in the further cases we'll be seeing many more problems in this chapter. The most important thing is you have to pay attention and you have to know how to find the log and anti-log. Is that clear? Okay.